Is it working? Oh, I'm seeing something. Could be working. Okay, let's assume it's working. So that should be live. Okay, so what I was about to do was get back to actually streaming the code, but then apparently OBS crashed, and then I brought it back up again, and nothing seemed to be happening, but I had already at that point started explaining why OBS was crashing. So I guess I'll just go back and rant again about why OBS was crashing. Because presumably now people will hear my rant. Hooray. Maybe. Anyways. Yeah, so I just switched my stream back on, was about to start getting some code written when I was told that nothing was going out. When I switched back here, OBS, which is the program I use for actually streaming stuff out from this machine for capturing the screen, which is what you see here, nested infinite deep, was gone. OBS was gone. And apparently because it crashed without making any noise at all, which is kind of odd. But as I was also about to say earlier, is that this is... Oh, okay. Don't do that. That was scary. So, OBS is... The version I'm running here is the latest version you can download from OBS. Here, the website itself. If you go here, download this version here, you can do this. I did this, but the version that comes with the default, or in the default repository in Ubuntu, at least in the version I'm running here, I think is outdated. It's kind of hard to tell because it just says 001, and if you go, I wonder if I can, maybe here, does it say somewhere, please? Does it? Yeah, so the thing is, they claim that the packages that they have out are for 0 something something, but I'm pretty sure that's the version I've installed here, which is still 011. So I don't know exactly where I'm supposed to see which version this is, because it's clearly not just 011. Maybe it tells me somewhere in here. 011, no. Yeah, me. But anyway, the version I originally had installed had a tendency to basically it had pretty severe memory leaks, because as soon as I started it up, it would use the entirety of my 16 gigabytes of RAM. So the first time I started it up, it basically just crashed my computer because I had no swap. So when my RAM ran out, the entire computer just, basically died from, not having any RAM to put anything in. So I rebooted, added a swap file, which is new for me, and started it up again. But then it again filled the entirety of the 16 gigabytes, and then it seemed to stop around a couple of gigabytes of swap, and it showed the percentage of memory it was using was 88%, but it seemed to be stable at 88%. So I thought maybe it's just, very aggressively allocating a lot of memory for no good reason. But at least if it doesn't, continuously leak memory, it should probably be fine. I mean, all of that memory that it's not really using, it should be able to just, you know, swap out, and the rest of the machine should be fine. But after starting the stream, at first it seemed like it wasn't actually leaking, but then within like a few minutes, I noticed the swap kept growing, and the amount of memory that was being used was not decreasing. So even though the memory percentage seemed to be at a steady percentage, for some reason it was growing, and eventually it managed to fill up the entire swap as well of 16 gigabytes. So obviously I had to kill it at that point, because otherwise it would, again, you know, bring down the entire machine. So I had to go back, get the latest and greatest version I could possibly get of OBS. Had to fiddle with that to get it installed, because I'm using a different version of Ubuntu than they're targeting. And after doing that, everything actually seemed fine. But then, you know, a couple of minutes ago, it crashed out of nowhere. So, yeah, it doesn't seem like the best, the most stable piece of software, but I guess any piece of software that is version 001 is probably not that stable. Anyways, I think I've been ranting in long enough. So, still says live, good. Okay, so let's go back to coding. Okay, so while the stream was down and I didn't know it, I was trying to rewrite the assert here, because I don't like asserts, as I think I've firmly established by now. So I thought I could use the S format here, which should be a char array. Though obviously what I want is a string, and this does not seem to work. I wonder if I can I do something like that? Oh, sorry, that one. No. Oh, wow, that worked. That was interesting. Okay, so it seems like since S is essentially a char array and not a potentially infinitely long string that is zero terminated, you have to tell it how long you want it to read. So now I'm just reading out the 8 bytes here, and presumably it knows how to handle the last bit there. I wonder what happens if we do this. Yeah, it doesn't. Okay, so it does actually expect the last one to be... Wait, does it? I wonder... Does it stop early then? No, it doesn't. Interesting. Even if we say 10 here. Okay, so that works. Okay. So you tell it sort of how much to allocate, and then it reads until it gets to the 0 byte, and then stops. Okay, so let's see, 8. So, oh, I keep doing that. I don't want that here. Not now. I want it over here. Okay. Keep being distracted here. Okay, so now we have the string read out with all the other values. So now we can start making all the asserts. So if the magic is... it's not, that's what I want to say. It's not UNIRAST. Then, so now the question is, do we want to make this exception based, or do we just want to, you know, politely warn that something is wrong? It's a good question. I feel kind of like, in this case, unless we encounter a lot of weird files that are broken in subtle ways, that we still want to, you know, politely pass, kind of like is common with HTML, for instance. If we have a lot of those, then we don't want to raise exceptions every time. But in this case, I feel like we probably do, because if something is wrong with our files, we want to know about it as soon as possible. So raise an exception. Yeah. I'll get back to that. Okay, so we want to warn if the header magic does not match. And then we want to insert the magic. That's right. Header magic does not match. What? Interesting. Is that because it actually returns the 0 byte here? Oh, it does. Interesting. Very interesting. Okay. See, I did not know that. Now I do. Right. So, to explain that, I had assumed because whenever we had been printing these, it only printed the first 7 bytes, and you can't see a 0 byte here, escaped or otherwise, as far as I can tell, at the end of the string. So I had assumed that magic was length 7 and did not contain the 0 byte that we know is in this magic part of the header here. But it turns out it's actually there, and it's just because print either ignores it or eats it, or otherwise does not, you know, print it all the way through. So we weren't seeing it, but it was actually there, meaning that if we just matched against the string without the 0 byte, this would fail and it would claim the header doesn't match, which is, we can probably put this in a better way, telling them what it was supposed to match. Does not match. Oh. Something like that. No, that's kind of awkward. I don't know. I feel like that could be done better, but let's leave it at that for now. Okay, so definitely if we open the file, we look at the first 8 bytes and conclude that the magic string is not there, we just raise an exception saying, you know, this file, we can't pass it. It's clearly not the correct file format. So next is pages. Magic. Pages. See, this is an integer, and we don't know what the valid range is here. Because clearly, somewhere between 1 and, a few pages will be the common value, but could it technically be 0? Is that valid? It probably is. I mean, then you just don't have any raster data at all after the header. I mean, I guess that could happen. But what if it's, all 9s or Fs as it is, so yeah, I mean, what if this is actually how can I put this? If it's the biggest value it can possibly be, to the degree where there are so many pages, the file is probably exceptionally large. Perhaps more than the file format is otherwise defined to hold. That is another possibility, but since again we don't know what this file format is, or rather we don't have the specifications for it, we can't really say anything about that. So I think the best thing we can do here is perhaps check if it's 0 or less, then we want to warn about it. Reason why we don't say 0, we say 0 or less is because, good practice. Even though we actually know here, it can never be less than 0. If it's ever less than 0, something has gone horribly wrong. But nevertheless, let's just print a nice little warning string here. Warning pages is less than, or wait, pages, that's fine. Though, I don't know, that again that's such a bad warning. Maybe something like this is better. Let's go with that. Okay, so this brings us to bits per pixel. Sorry about that. And the bits per pixel is actually I should bring out that page as well. That was, I'm trying to remember. That was the cups filter URF. So it's not this one. This is not the one I was thinking of, but maybe it'll do. Yeah, okay, let's go with this one. So, sorry. I'm not sure where this guy managed to find this information, though I did find it on the cups documentation. But I suspect that the cups documentation actually got it from here, since this guy implemented the URF to PDF filter that goes into cups, which is in fact this thing right here. Right? But nevertheless, if we assume that these enums here are true, that means there are exactly 4 different values that are sort of valid values for the BPP. Namely 8 bits, 24 bits for 3 values, 32 bits for 4 values, or 64 bits for 4 double values. And you can also see, which I alluded to earlier, that the color spaces we actually do know something about. 0 being the grayscale, 1 being the 24-bit RGB, sRGB, apparently. I'm not sure this is true, though. But anyways, RGB, and then there are different formats of this, and I honestly don't know what this is supposed to be. Who knows? It's actually kind of odd why it's laid out like this, but is this supposed to be the default one? Anyways, yeah. The idea, therefore, is BPP is one of the values that we actually do know something about, and we can argue or reason about what a valid value is. So if BPP is, if it's not in the range of, and this should be an integer by now, so either 8, 24, 32, or 64. We want a 1, BPP, not in valid range, not in valid set, I guess. Not in valid set. It's kind of awkward too. Anyways, it's good enough. Good enough. Okay. Yep, okay. So now we want, if for some reason the image specifies a bits per pixel that is not somehow legal in these color spaces. So, next one, let's put it over here. Next one should be the color space, which again we know is between 0 and 6, both included. But we can do that. Let's do this. Like so. So if it's not, okay. If it's not a value between 0 and 6, both included, again we want to warn the color space value it's not valid. Here we can use range. Hooray. I know. This goes beyond 80. Do I want to? No. Let's not go down there. Oh. Color space value is not a valid range. Because it's 1. What? What? This should work, shouldn't it? I could have sworn. This should be greater or equal 0. Less equals 6. Right? This is... Oh, right. Because we're using B. Wait, but... Okay, okay. I have a suspicion here. This is again one of those things that you don't notice if you just blindly rely on print to show you. No, okay. So my suspicion was that since B refers to char, it would return a one length string, because that's what a char is. But it does actually say the Python type here is integer. And this also says it's an int. So that's clearly not the issue. So I guess this doesn't work, which makes me sad. Why doesn't this work? Oh. Dum-de-dum. Okay. Yeah. Look at this. Yeah. Nice, right? I'm doing this to you. Oh. Doesn't actually work. Okay, I'm not doing this to you. Oh man, I thought that would work. I'm clearly not as good at Python as I thought I was. Oh well. Okay. Let's pretend that didn't happen. Okay, so duplex. Duplex is also an enum, that is an integer, between 0 and 3 in exactly the same way. So let's just do this. Duplex value is not in valid range if duplex is not between 0 and 3, both included. Boom. And next is quality. Quality 2 is an enum, but between 3 and 5. And that is very interesting because no sane programmer would implement this or define a standard like this that starts at 3 with the values 0 to 2 being undefined. So I will almost guarantee you that out there somewhere there are documents that will contain these values. Anyways, let's just one for now and take it up once we do encounter one of those mysterious documents. Oh, I see there's a space there. Quality value is not in valid range. 3 and 5. So this actually reminded me that some of these, for instance this one, we can probably make an exception as well. But I don't know. I don't feel motivated enough to do that right now. So let's just skip ahead. Let's just make them warnings for now, and don't want to print those. So this is also interesting. What is a valid page width? That's probably the same as the number of pages, in that you could technically have 0 width or height, but of course it wouldn't really make sense if you're trying to use the file for anything. But that means, do we want 1 if it's 0? Probably. Okay, so page width is less than or equal to 0. Page width found. And we basically just copy that for the page height. Right, okay. So, page width, height, DPI, okay. And again, the same story. It could potentially... Okay, so here's something interesting, actually. DPI only makes sense if it's... Okay, I'm trying to think here. It generally only makes sense if it's a non-zero value, a positive integer, or actually a positive number, I should say, because here are some things I found out personally about the JPEG and TIFF formats. I believe the TIFF format allows you to define non-integer DPI values, which I think is interesting. But more interesting perhaps is that the way you encode DPI values or resolution values, as they're called in JFIF, JIF, I don't even know, JFIF, which is a tag format that is embedded inside or can be embedded inside of JPEG files for various metadata. The way you do that is you can either set it to a positive integer, non-zero positive integer, or you can set it to 0. 0 meaning that, or perhaps I think it's 0 DPI. No, wait, 0. Let me see if we get this right. 0 in the unit value and 1 in the DPI value would mean not that the DPI is 1, but rather that because the unit is 0, that the pixels are merely square, though the size is undefined, which is sort of like the default value if there is no other information. So a DPI of 0 is perhaps technically not impossible. So I think maybe it makes sense to just leave that as it is, like so. Though obviously, again, we can't necessarily say that just because this is the way it is for JPEGs, this is also true for URFs, since we again know nothing about URFs. But let's try and not assume too much in either case, and let's leave it at this, saying that DPI can be practically any value. Whether it makes sense is a whole separate discussion that we of course can't do here. So let's run it, make sure everything works. Why are we still seeing values being printed? Print, raise. Wait, what? Oh, I forgot to hit save, run. Okay. Okay, so this seems to be working. Great. Okay. Let me just quickly check on the stream. It claims we're still online. So that's good. Okay. So perhaps now is a good time to quickly summarize what we're doing, where we're at. So today's stream, I'm trying to implement a small program in Python specifically that will be able to parse and preferably also produce, both encode and decode, that is, URF files, which is this, okay, which is this format for sending raster data from iOS devices to printers over the network. So it's kind of it's akin to the Pt.2 raster format, and the main difference is that this particular format is not an open format, and very little is actually known about it outside of Apple, who came up with it and has said nothing about it as far as I know. There are no specifications, there is no open source implementation of it, save for a few people who have implemented either filters for cups or various other, actually I think this guy has another program in here. Is it this one? Yeah, so he has another couple of programs here for basically taking URF formatted files in, decoding them, encoding them, and outputting them as BMPs or TIFFs. But again, this is all based on the same single reverse engineering done by this one guy. So, yeah, so where we're at right now is we've made a parser for the header. I should probably say header here. Parse header, and define another parse function. That does this. We just take the data. Again, we can always go back and clean this up later on, like so. And we should, of course, also call the parse header here. Okay. So we passed the header. We've made sure the magic is there in the beginning of the file, this particular string. We've decoded all the different bits of meta information in here, or at least the ones we know about. There are still 4 or more fields, depending on the width of these words. And yeah, that's all the meta information we can get out of this file at this point. But how do we return this? See, usually I tend to be lazy if I'm just coding on my own. I'll just return like so, like a very bare bones tuple of all the values, where the positions are of course significant. Making it a name tuple would probably be better. But as I said, I tend to be lazy. So, oh, actually this is a perfect place to show you what I was talking about earlier. So we can say headers here. Something like this. So of course it's kind of ugly that we had to split this here, though. I wonder. No, we can probably not do that. Okay, so this is neat. At least I think so, because it allows you to save all of the headers in one tuple and unpack them into individual variables here. Which, if you were to do it otherwise, you'd usually, just have the headers, and then you'd do this, and you'd either do this, and then, header 0, and header 1, so on and so forth, which is a huge pain. Of course, maybe we don't need the header there. Maybe we don't need these here, but let's just leave these for now, because we were probably going to need one or the other at some point. If we need to send these off elsewhere, we might want to just send off the header as a tuple. If you need them individually, it's nice to have them unwrapped here and named. So let's leave that for now and move on to parsing the actual meat of the thing. The body of the file. So, okay. So the first file, he only reversed the header part, and then says anything after that is the body part. Body part. One thing that immediately springs to mind here is, how do we tell how long the body is? Because I haven't actually seen anywhere in here that would indicate directly how many bytes we are to read after the header. Usually a lot of formats, especially the older ones, stream now requires a not safe for work tag because of the body parts. Could be. Yeah. Who knows what we might find if we dig deep enough into this file format. Anyways, what I was saying, maybe I actually already forgot. I was talking about the body here. Yeah, okay, so I was talking about the length of the file, of the actual body. A lot of older formats, I think things like BMP, bitmap, I think even, of course, things like HTML and so on and so forth, they practically all have a field in the header itself in a predictable place that will tell you exactly how long the actual content of the rest of the file is, or the stream or whatever. Because especially if it's a stream, you want to know how much you need to allocate ahead of time, because you can't just stat the file on disk, and you want to be able to tell if the file is potentially truncated. But I'm not seeing that here, which is kind of odd. We just have the header followed immediately by what looks like raw pixels, raw raster data. Of course, we could speculate that maybe some of the unknown fields are for the length, but again, I'm the only one that is a non-zero value is this one, and that one is 1. And clearly there are a lot more than 1 byte down here. So I'm guessing probably what they did with this format is that they basically said, we don't need to write exactly how many bytes are in the body, because we could derive that from some of the other information that will be there anyway, namely the bits per pixel and I'm guessing this is the pixel width and height of the image. Yeah, I guess DPI doesn't actually affect that. But you would essentially have 24 times 5100 times 6600 pixels. Oh, sorry. These are the pixels times this many bits. And that would tell you exactly how many bytes are expected. But that also, I guess, indicates that there's probably not... I was going to say that probably means that there's not going to be a footer or any kind of information following that. Because we don't have a sort of pointer to that. But then again, I guess this is also a pointer to the very end, but we don't know if there's anything after that. We'd have to try and read it and potentially fail at that. I don't know if... Maybe that's what this is? Who knows? But I think it's safe to assume that we can derive the amount of bytes in the body by multiplying these numbers. And this, of course. And then potentially ignore anything after that. Though it could be interesting to see if you can find any examples of where any data is found after this many bytes. So, let's try that. So the first thing we need to do is, of course, to say BPP, and we'd want to divide that by 8. So bits per pixel. If you want to say bytes per pixel, that is a bit unfortunate. So let's say like so. Do you happen to know this one? I wonder. And yes, there is a difference between saying this and this. So this one, of course, is the standard division operator in Python. This is, I guess, the non-standard. This is the integer division, which is kind of odd because this will also do integer division if the two inputs are integers. And since BPP is an integer and this is an integer, this will also be an integer division, and the output will always be integer, even if, say, we divide by something that will give us a non-integer value. It'll simply, again, cut off any decimals or... actually, I forget if it does rounding or just rounds down or whatever it does, but it mangles it no matter what. So, but in this case, let's just say we always want an integer amount of bytes, because please. So bytes per pixel width height should give us the amount of pixels. Let's see, like so, and then body bytes is the amount of pixels times should probably be plural, bytes per pixel, body bytes. Yeah, you're welcome, by the way. Okay, that's a lot of bytes. How many bytes is that? 1K... That's not 100 megabytes. I forget how to do this. Is that right? Wait, am I doing this wrong? Actually, how big is this file? 70 kilobytes. Oh, interesting. Now I do wonder if this is not the actual canvas size as much as the sort of print document size, which it, oh, sorry, again, knocking the microphone. This could definitely be the actual document size and not the, like the canvas size of the image that we're trying to print on the document. In which case, this would often be a lot bigger than the actual image, and therefore the amount of pixels. But again, I don't know which unit this is in. Perhaps we can find some interesting information in here somewhere. To PDF. Let's see. Width. No, this does kind of indicate. Oh wait. Thinking. Let's just for measure here. I didn't accidentally turn this into bits. No, I didn't. Right? Oh wait. The width, of course, would not be per pixel. Yeah. Yeah. So, but that's still stumping. Okay, so what I was thinking just now is the width, of course, would be the amount of pixels, but each wait. Bytes. Yeah, so what I was saying is that since there are multiple bytes per pixel, the sort of page width in bytes is, bytes per pixel wider than the width in pixels. Did I say that right? I'm not sure. Nevertheless. Okay, let's I don't want to waste too much time on that because there is one other out here. Because I noticed when we started actually looking at the raster data itself, which I think is only decoded for the second document here. If we look at the first one here, it says line repeat code. Okay. Yeah, so I guess we have to dig into yeah, okay, that makes sense, I guess. So this, I think, would be the total amount of bytes if we were to save the raw uncompressed bitmap with bytes for every single pixel in all the different channels for the color space. But it looks like the UNIRAST format uses something called packbits, which I'm assuming is a compression algorithm. So let's see here. If the code, which I assume is simply whatever byte is being inserted here, is 80, so this one, the algorithm says fill the rest of the line with line byte, or with fill byte, whatever that is. Otherwise, if it's a positive integer, sign byte with 3 interpolation, okay. It repeats that thing. Otherwise it inserts that thing. Interesting. Interesting. I've never seen this algorithm before. I don't actually know how TIFF does it. But yeah, it seems fairly straightforward. Though I guess if we're... Yeah, if we're already unpacking the raw bytes or setting, essentially painting the canvas, I guess now is a good time to introduce an actual canvas here. But I kind of want to cheat a little bit and just write a really naive parser here. And I'm being told the packbits format is very old, released with Mac Paint on the Macintosh. That is quite old. Surprising. Though I kind of get a feeling that a lot of these image formats are quite old. Even JPEG is like very early 90s. I saw it had like special case implementations for DOS. TIFF, I think, is also like the very first version of that is around the same time, I think. GIFs, GIFs, I think are also early 90s, I would guess. Yeah, when I was looking into JPEG earlier today, I also kind of realized how much of a mess JPEGs are. So, actually, I kind of want to show this. There we go. This is what I was talking about earlier. JFIF. So, JPEGs. My understanding is that JPEGs essentially use YCBCR internally to encode and store the image data. But if you look here under the color space, it says JPEG does not actually define what color encoding it's using for the format. So yeah, but then of course they added JFIF later on because they realized like, oh, you know, maybe that would be nice to have information and stuff. So JFIF essentially extends the color models available to grayscale and YCBCR. But that's again not an absolute color scale. But then other things were added to embed ICC color profiles. And then Adobe came along and made their own header or tag format that you can embed inside of JPEGs that will that are kind of like these, that will tell you all kinds of things about the color space. So they, like, if you use the Adobe header format for JPEGs, you can set the color for the color space to CMYK and get a so-called absolute color space, which is really nice. Except if you use their header, they do not have the density units, and they don't have DPI either. This is, by the way, what I was talking about earlier, about if you set no unit and you set DPI 1 and 1, you would get like square pixels. There you go. But so if you use the Adobe headers, you can't use the JFIF headers, because then apparently decoders get really confused, because they each define mutually exclusive sets of color spaces. And if you include a JFIF header, you can only use the so-called legal color spaces, which are grayscale and CBCR. And if you use Adobe, you can use actual useful color spaces such as CMYK and I think probably Adobe RGB, or maybe it's sRGB, I don't know. But nevertheless, but then if you do that, you lose the ability to supposedly encode the density, because you'd have to use the JFIF header for that. And having both of them is a possibility, technically, but as far as I was reading, it's strongly discouraged to do that, because then the actual color space information is very ambiguous. But yeah, this was apparently defined in 91, and it's been updated a couple of times since. And interesting, when I was looking for the JFIF specifications, which were previously available on JPEG, the JPEG Group's site, that file is no longer there, and I can't find any link to the PDF anywhere. So I don't know if they retired that, or they decided it's too sensitive information and you have to be a member of the group, pay them a giant license fee to access it now. But yeah, that's a mess. That's what I wanted to say. Yeah, so I'm not surprised that this pack bits is very old as well. Yeah, let's move on. Okay, so def pass body. Oh. So we want the data. Wait, does this? No, okay. What happened there was that I have a mouse that has ironically it has a DPI setting, an actual button for setting the DPI. So if I turn it up a lot, my mouse flies around. Usually I have it quite low, because it's nice to be able to point at things. But I was just wondering, if I increase the DPI, does that change the scrolling speed? But apparently it doesn't, so that's kind of useless. It's kind of low, isn't it? I'm scrolling a lot right now. And throwing my mouse around. Anyways, aside. So. So we wanna loop through just the body pod. And it seems like we can take it byte per byte. So, and also, if I'm not mistaken, yeah, it does look like the header is a fixed size, a static size. So we can probably just take from 44, because that's 32. Yeah, 12 plus, yep. That looks about right, right? Okay, so this is the body. Now we can say for byte. Byte is probably a wrong, bad word to use here. For body byte. And URF body. If it's 80, then fill the rest of the line with fill byte, whatever that means. Yeah, I'm not entirely sure how to interpret that. Does that mean we're just... Oh, is that what that means? Is this might be the filler? Oh no, no, yeah. See, I thought I understood what this was supposed to do, but now I'm suddenly not too sure. Anyways, let's move on. So if it's... Right, if it's less than... It's this one. If it's greater than, we should be here. This is great, by the way, to have the chat. It's essentially like doing pair programming, which I've never really done. Well, I guess maybe we did it in school. I guess that was pair programming. But yeah, I've definitely never done this before. That's pretty cool. I don't know. Do we want to do this in here or out here? Yeah, we probably want to do that out there. I think so. Right. See, this is one of the things I really like about Python. Things like strings and like random, just like, what do you call this? I want to say statements, but I'm sure that that's not the word I'm looking for. But nevertheless, you can just essentially dump garbage in here that is technically meaningful, but it's just a placeholder. Because Python is indentation based, sensitive, I guess, it needs something here to be able to figure out what goes where. So you saw it complained about the indentation when there was just a comment here, because the comment is essentially invisible to the parser here. You can put a comment anywhere and it doesn't like affect the indentation passing. So that means you can't just leave this body empty here, because then it would get confused about what was supposed to go in here, and this looks like it's indented wrong because this should probably have been in the body here. But you can put garbage in here, like a string or none. I like to use none because it is the perfect nub. But yeah, you can just leave a string there. Doesn't matter. It's fine. Still works. I mean, it passes and runs. It might not actually work. But, oh yeah, I intended to move that thing. Did I? Yeah, I did. Okay. Okay, so it runs. But yeah, that's what I meant to say, is that's nice to be able to do this. Just leave that there, because it means you don't have to, you know, write dummy code that is like logically dummy code, but you can just, you know, fill anything in here. Yeah, pass is a possibility, though I feel like the reason why I don't use pass is because if you're inside like a for loop and you're doing like for ein range blah, and you're doing like if you know, there's something here and you're like, oh, you know, I have to implement this later on, but you know, I don't know, I'll just, you know, fill this in later, and then like, oh, you know, you want to do a pint here, then here you can't actually use pass. Wait, or am I confusing it with continue? You might actually be right. I wonder if this works. Let's try it out. Oh wait, right. Also, we should probably use 98, just because. Oh yeah, you're right. Yeah, I was thinking of continue. Yeah, huh. Oh, well, today I learned. Because yeah, what I was thinking is, or what I have been thinking in the past, is that it essentially works like continue, which if you paid close attention here, you'll see that it actually means that you're skipping out of the rest of the execution here, so it doesn't work as nice. But yeah, none does the same, right? Pass, none. Oh well. I guess it's because I always forget pass exists at all, and none is pretty much an up. Oh well. Well, we're all learning stuff. Isn't it great? So. Right, this is essentially the pass loop that they have here, except without the logic. I guess we can compute some of these values. Pixel size. Oh right, yeah. I'm so rusty in actually reading C that I look at this and assume it's a read operation in a or a lookup operation or whatever you might call it in an array. Though I believe this is how you allocate things, right? I don't know. This just looks weird to me because I feel like didn't it used to be, way back in the day you actually had to write something on the other side of the equals something or other. I don't know. Yeah. So n is essentially just whatever the input was plus 1. I wonder... Nah, let's not delve into that. Add pixels to line. Oh, okay. I think I'm beginning to understand this code. Which I guess is nice. No, I'm still puzzled, frankly. So you have this there, you have the unknown, 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 then you have the raster here. So if FF 80, 9B 80, 01, then you would have 7F. But I'm having a real hard time figuring out what is like an upcode and what is supposed to be raw data. Yeah. Yeah. To paraphrase, the data comes from the magical read data here. So this one refers to this one. This one is the same as this one. So this just reads from somewhere. I guess I should be thinking it out here. So I'm just trying to go through FF. It would be here. And it would read data into the line pointer. And then it would break. We go to the next one, presumably. Which I'm guessing is that one. Which would then fill the rest of the line with fill byte. No. I feel like this is not enough information. I should probably try to look at this. Oh, it's fast and simple. That makes me feel great. Right, it's a run length encoding, which is a word I remember. Right. Yeah, see, this is what I would have expected, right? So it's a data stream that consists of packages of 1 byte headers followed by data. The header is a signed byte. Oh yeah, signed byte, right. The data can be signed, unsigned, or packed, such as blah blah. So the header byte, literal bytes of data. It's literally a byte of data. Very nice. It's simple because it doesn't have an audio jack. Yeah. Oh man, what was the name of that thing? Oh no, yeah, this thing. Supposedly doesn't have an audio jack either. Oh, the SP? Is that what it's called? Oh, look at that thing. See, I've been meaning to make my own kind of thing like this, with like a huge battery, a couple of buttons, an LCD and a Raspberry Pi Zero. I would love to have one of those. They were ahead of their time, right? Yeah. Lots of courage. Anyways, okay, so this is kind of what I was trying to say, that I suspected this is kind of like the way bytecode is done anywhere, like assembly, or I guess bytecode for the Java virtual machine and whatnot, in that you have sort of the opcode first, and then you have, or I guess you can say it's like a multi-byte opcode, where the data is whatever follows the actual opcode part of it. Yeah, yeah. So I think what he was trying to say here is that the first one here is the actual opcode, and this is the data. So, but does it make sense? Does that make sense? Oh, okay, yeah. I think I see. So that means FF, which is -1, right? I'm not making this up. I'm pretty sure it is. Oh, okay. Yeah, so they're... Wait, what? There... Isn't this already an int? Which means if this is -1, this would be 1 plus 1 was 2. I would kind of have expected this to be the other way around. This would be the highest possible, which is why there are some leftovers here. Anyways, so supposedly that means it's 1. We copy the next byte here, 80, exactly 1 time. And then we loop for the next one. 9b would be somewhere in between here, which again means we copy it some amount of times. But that's also 80, which is why I don't understand why, if this is 1, why isn't this just this thing plus 1? And then we could get rid of the 2 first lines. But anyways, let's assume that is the way it works. Then this one would be 1, which would be here. Oh no, I'm misinterpreting this. But then, isn't this wrong? Because this one will be 1, so you copy that 1. Then this one is multiple, so you copy this one, right? Plus a bunch of others. Okay, at least I think I've gotten the pattern now, assuming this is right. So, yeah, let's try to do that. But first, I think I'll take a quick break, get some more coffee. So let's try to see if this works this time. Maybe the OBS will crash again, but let's find out. Ooh. And we're back. Let's see if it works this time. Or if it crashes again. Might be good. Oh, I'm seeing something. Yeah, okay, it looks good. So I was thinking it's kind of silly to re-implement pack bits if this is already a well-established standard way of doing things. And I was gonna essentially just rely on the library to do this for me, because there's no reason to re-implement something that is readily available everywhere else. But then I also realized right after that I think what they're actually saying is that this is not standard standard pack bits. So I probably can't just use whatever library. So yeah, I guess I'll have to just make a quick naive implementation of this, which is fine, I guess. It's fine. But let's try it out. Let's see if we can actually make this work. So to work with the canvas, which was talking about earlier, there we go. I already have some code that I did earlier doing something along those lines. So we can use the PIL image manipulation library for Python. It has a image module for loading and saving images, fairly generic images, and you can save it multiple different or various different file formats, as well as an image draw library or module in the library that allows you to draw either shapes or actually, I forget if the base image just supports putting pixels, or you have to use the image draw for that. Possibly you have to use the image draw. Sorry. So let's see. Yeah, so let's copy that. Okay, let's just dump this in here for now. You also need, yeah, so you can draw an ellipse. You can get pixel, but you can also put pixel. So we're also going to need that one. But that one is just quickly see here. Okay, so you can, I think you can at least get pixel on non-draw images. But we also need to be able to open the image and save it for that matter. Or I think there is a .show which just opens a window that will show you the image, which is probably fine for what we want to do, just for testing. We need the open image though. Okay, I should just open there. Okay, yeah, it is just image that open. Actually, no, not. We don't need open. We need new. Is there such a thing? Yeah. Okay, this is what I wanted. So first of all, we need to create image with image that's new and oh right. So we need to set the mode, which is to say the color space that we're using. This is just the background image, or background color, by the way. Wait, what did I do? Okay, no, yeah, looks good. So I think we're just going to do RGB size. Yeah, actually, let's. Yeah, maybe we don't need this. So let's take this one out here. And we know the width and height, which goes in a tuple here. So I think this is just black. So maybe we want to do this. Oh no, because this is RGB. Yeah, it has to be a 3 tuple, I think. So again, this of course is RGB white. So there. Now we have a blank canvas white in the size that we want, and in RGB. So we're just assuming RGB now, for now. Though obviously we can check the color space later on. So image, oh no, yeah, okay. So just get pixel. But there is also a put pixel, which takes the pixel and the position and the color of the pixel. So again, a tuple. Though actually that's kind of interesting. Going to have to decode that, of course, out of whatever data we get here. So oh yeah, I guess to be able to do operations like fill the rest of a line with something, we need to figure out how much the rest of the line is and exactly where that line is. So we kind of need to have access to the current X and Y. And I guess we can't derive that from the body. So I guess we will have something like X and Y here. How do I want to do this? I'm not sure. But let's leave that there for now and come back to it. And then we essentially need 4 loops within this. This and this, right? This needs to iterate for the rest of the y, or the rest of the x in that y. This needs to iterate over the next n from the position xy, the next n x's in the, like, from the current xy. And this needs to iterate over from the current xy, but n plus 1 yeah, n+1 pixels forwards. Interesting. Okay. So this won't really work, I realize. So let's do this. Because this way, if we just take one byte at a time, we won't be able to address, you know, the next n bytes, or yeah. So let's try. I'm contemplating the relationship between bytes and pixels here. It's not clear to me whether the data is strictly bytes or is supposed to be if it's supposed to be pixels, which would mean we need to cover multiple bytes. Oh well. Actually, I guess we'd be able to tell in the end if we have enough pixels produced from this. Enough bytes produced from it. So let's just power ahead and see what we get. We can always go back and figure out why things aren't working when we inevitably break things. So maybe we need to have a shortcut to the current code. Is that what they call it? Here. Header byte. Okay, yeah, let's call it that, code and data. So the code could be one of these, and so in that case we would copy the next data would just be this one plus one. And the output would be data times, and n of course is plus one, like so. Copy the data. Oh, n plus one times where n is, yeah, me. Okay, so this, oh, right. So we have to make a range out of this length. Interesting. That was not what I expected. Having a hard time believing that they're all there. Are they? How exceedingly unlikely. Are they really all this one operation? Okay, so copy the following. Where it's code. So it's minus code is 1. It's n. Oh, right. I guess I need to unpack this as a signed byte, because right now I think I'm just... I guess that shouldn't matter for these. But it could matter for these. I do wonder. This should be n. Right, I can't do that. Okay. So yeah, I should probably unpack here. That means we need a sign char b. Oh. What am I doing wrong here? Oh. Okay, it definitely feels like something is wrong here. Because the fact that we end up getting a... Oh. No, okay. I'm getting tired. I can feel. Thinking too much. But yeah, it feels like we're probably doing this wrong because all the bytes should line up. We should not end up in a position where we try interpret the last byte as a code and then try read data after that. That is not there. I mean, it could be a... It's definitely a simple off by 1 because we're iterating all through all of the i's. So you should really do so while I is less than this, and then we need to increase so if there's only 1, I'm still not sure what exactly this is supposed to mean. I guess we would still need 2, right? Because there's AD and then the filler byte after it. That's what it means, right? I think so. But then yeah, so this one is the code plus a single pixel. I'm not sure. And then this one is the difficult one because it's 1 plus n, I think. Interesting. Now we're probably hitting a an infinite loop, but not in this case. Still out of range though. Okay. Now it's only this one we're getting. This again is fairly odd. Okay, so the first one is supposed to be 7. Just double checking here. What is this one supposed to be? Oh, okay, yeah, so it starts here. But then, why does it say rest of data starts here when you have garbage there? Is this supposed to be the length? No, it's the same between the two. Can't help feeling there's something wrong here. Oh well. So it's supposed to be FF for the first one. Which just brings us here. Which it seemingly isn't. Interesting. Okay, I think I need some music to keep my brain going. I wonder if that's going out into the stream. I don't think it is, right? Shouldn't be. Okay. So I think since I can't quite make sense of the test data we got from this place here, I think a good place to sort of fall back on is to try and make sense of this test data they actually have right here. So one thing we can do is try feed this data directly into this function here. So say pass body byte string. Then we go through and escape all of these. There. Okay. So now we know. Let's need this one actually. There. Ooh, I love this music. So we know this input data is supposed to produce this output data, which is very useful because it means we can run this through here and know exactly what to expect. Though of course we need to quickly comment this out. There. It's still out of range, so we're definitely doing something wrong here. So the first one it says is -2, which I think is correct. Because FF is -1, FE is -2, so -2 FE. Oh, is that what I'm doing wrong? Yeah, because now that I'm unpacking this, -2 will be less than x80. Which is clearly wrong. Ugh. Ugh. Okay. Sometimes you do these things. And it feels incredibly stupid once you realize. Of course, this will make this not work, but that means we can put this here. Okay. We're beginning to see some interesting data. Oh yeah, because I'm debating whether or not I want to try and print this in hex. See if I can remember how to. Or is it H? I think it is H. No? It's not E, right? Ugh. Python format. It is X, right? So I'm not reading it right? Unknown font code X. For object of type string. Okay, so wait. Maybe like so. Hmm. No, that doesn't work, right? No, it doesn't. Wait, why doesn't this work? See, this is what happens when you code for too long. Your brain gets really fried. Anyways, it doesn't really matter so much, I think. Worst case scenario, we can... Yep. So I guess this should really be int. Yeah. So this is -2. So we're just going to do this to make it a little clearer. Yeah, so -2, we do end up down here. Good. Three. Oh, okay, yeah, that comes from there. Okay, okay. Ugh, I was trying to figure out where that 3 went. Because this one should have ended up here, but I wasn't seeing this line. But of course, that 3 was not coming from up here, it was coming from down there. Okay. Okay, so -2. We have here. And I will have to go offline.